Hi. We will discuss a very interesting lesson or session today about the force. What about the force? What do you know about the force? Force is a push or a pull. This is simply it's a push or a pull, as you see. Force can cause any object to change its direction or speed. Force don't always cause object to move, like the chair. If we see any chair, it will remain as it is because the gravity as distance force, as we will discuss, make this chair stable in its place without any movement. The unit used to express force is Newton. And okay, force could be act directly, which we call it contact force, like friction, any two objects in a contact. But from a distance, we can find another type of force act at a distance like gravity or magnet force. So we have two types now of force. Here is contact force and the Earth's pulling force, gravity. This is the act at a distance force. Okay. Usually more than one force is acting on an object, and the combination of the sum of all these acting forces on an object is called net force. Net force can be determined based on the direction of the forces. Either I will make the sum or subtract. When two forces act on an object in the same direction, I will make the sum. Like first force was 1 Newton, the second one 2 Newtons, so the net force will be 3 Newton. But when the two forces are in opposite direction, we will subtract the smaller one from the bigger one. 2 minus 1, 1 Newton, the result. Also, we can classify forces balanced and unbalanced based on these net force. In balanced force, net force is 0 Newton, while in unbalanced one, net force is not 0 Newton. Balanced force, it will not cause a change in the motion of moving objects, but unbalanced will make the change. Also, for balanced force, it will not make the non-moving object to move, but here it will do, and even the moving object will change its speed. Okay. Here, for the unbalanced force, it not only will change on the speed, it also will change direction or both. So here we can, if you recall the acceleration, the change in motion is called acceleration. So what's beyond acceleration? The reason was the unbalanced force. And the acceleration is always in the direction of net force. Okay. Here, if we take an example, hanging light from the ceiling, it will not be changed because the gravity pulling the lamp downward and the the wire hanging the light is pulling it upward, so it will be remaining at its place. Many objects around us have a balanced force acting on them, and this is an example. So now we know the difference between balanced forces and unbalanced forces. Balanced and unbalanced forces, example, here is the balanced one, 0 Newton, because the the first force equals the second one. Here, unbalanced force. Force and motion are related. Yes. So now we go for the motion laws for the British scientist Isaac Newton. Isaac Newton explained the relation between the force and motion in three laws. The first law states an object at rest stays at rest and an object in motion stays in motion at the same speed and direction. No change will be happened unless it experiences an unbalanced force. So if unbalanced force will be applied on this object which was at rest, the status will be changed. But if there is no any unbalanced force applied, it will remain as it is. The same for the moving one. See this lady? These frogs will stay as it is. Now she's experiencing unbalanced forces on it, so it will not stay at rest. So Newton's first law, called also the law of inertia. Law of inertia. Inertia is the tendency of all objects to resist a change in motion. An object will not move unless unbalanced force makes it to move. And here is the example. Another, some chair will not slide across the floor unless force pushes the chair. So this is the first law of Isaac Newton, first law of motion, that all objects at rest will remain at rest and moving objects will still move, same speed, same direction, unless unbalanced forces applied on it. An object in motion stays in motion at the same speed and direction or velocity unless it experiences an unbalanced force. Here, for the driver, the unbalanced forces is the brake of the car. Now he is acquiring all the speed, direction, velocity of the car, but when the car stops suddenly, still this man has the same speed and direction of the car. That's why the stop, after the car stop, he will go upward. That's why the airbag will save him to be to crash or to be to face the front glass of the car. What I mean, the unbalanced force here was experienced on the car was brake, pushing the brakes to make the car stop. Still the man is on the same speed and direction, so is going forward. Let's go for Newton's second law, which states that the acceleration of an object depends on the mass of the object and the amount of force applied. This was the second law, that acceleration of any object depends on two factors: the mass of the object and the amount of force applied on the object. So objects that have different mass will have different acceleration if the same amount of force is used. Here, this object, changing in the mass of this object, okay, if we apply the same force pushing this vegetable car, it will be easy to push, and after filling with vegetables, changing in the mass will okay, so it will change its acceleration, or we will push it in a slower rate. Force F, mass M, and acceleration A. So according to the second law of Isaac Newton, that acceleration depending on two factors, the mass and amount of force applied, so we can formulate the law as A equals F, force equals mass multiplied by acceleration. So acceleration equals force divided by mass. Same mass equals force divided by A, and Newton is defined as 1 kilogram meter per second square. Why? If you see this equation, force equals mass multiplied by acceleration. So if the mass unit is kilogram and the acceleration is meter per second square, so 1 Newton equals 1 kilogram meter per second square, which is a force that gives a mass of 1 kilogram and acceleration of 1 meter per second square. Okay, let's go for a very simple problem to solve it according to this formula. A player is trying to push a massive object with a force of 150 newton. The object has a mass of 75 kilograms. What is the object acceleration? Remember, 1 Newton equal to 1 kilogram mass per second square. Okay, it's trying to push this mass. So we will put the formula on the equation. F equals ma. F equals 150 Newton. We will substitute with the given information equals mass 75 kilogram multiplied by acceleration. So 150 kilogram meter per second square, which is the 1 Newton equal. So it will equal 75 kilogram multiplied by A. So A will be 150 divided by 75. So result will be 2 millimeter per second square. Newton's third law states that whenever an object exerts a force on a second object, the second object will exert an equal and opposite force on the first one. Okay, so there are action and reaction. It exists even when there is no motion. Try to do it for the wall in front of you. Push the wall, nothing will change. Sitting on a chair, also this is an example. If you are sitting on your chair, now your mass or you are pushing down. Why are pushing down? Also the gravity is pushing you down, and the ground itself pushing you up. So the result, nothing. Forces in pairs has equal size but opposite directions. If you see swimmer pushing versus the wall during the turn, I know swimmers know what I mean exactly. That makes wall will push the swimmer in the opposite direction. forces can act in multiple pairs. If you see for the baseball bat, baseball player use a bat and ball and his arm to push the ball. So on the ball, we have multiple pair forces, the bat itself and the player's hand. This is examples of forces applied using multiple pairs. But the meaning of the Newton's third law that each action has a reaction. So whenever an object exerts a force on the second object, the second will exert same force equal but in opposite direction to the first one. This is an example of the multiple pairs. Now we go for just two problems. A cat having a mass of, it's like a small car or pushing materials and something like that. Having a mass of 75 kilogram was pushed with a force of 225 Newton across a very smooth floor. Across a very smooth floor, that means ignore friction, no second force from the floor. What is the acceleration? We will put the equation normally, and then the force, the net force equals the net force, which is F equals mass 225 sorry, I'm telling net force F equals 225 Newton, and mass we have 75 kilogram. So acceleration is missing. So usually when you start to solve any problem, start to mention or write the given information and write the equation. Before you start to solve it, write the formula or the equation. Then I will write the given information. Then I will substitute. Okay, so now A equals force divided by mass. Force is 225 divided by mass 75. So acceleration is 3 meters per second square. Very easy. Okay. Okay. We call here force is equals to the net force because there is no any other force applied that is telling you ignore friction. Same here for the second example. How much force is needed to push a crate of 75 kilogram mass across a very smooth ground with an acceleration of, I will put the equation, put the given information, then I will substitute. This is the equation. F equals mass multiplied by acceleration. Net force equals, this is the needed information, but we have mass 75 and we have acceleration. So now we will substitute. F equals M multiplied by A, 75 multiplied by 5, so it is 2 Newton. Okay, so I hope it was a very easy lesson, and do more practice. Wishing you all the best, and